students, Assalamu alaikum. Our lesson is about the preparation of a solution by dilution. At the end of this video, you will be able to describe how to prepare experimentally solutions having different concentrations starting from a standard one. Please prepare your pen and your chemistry booklet. First of all, let's make a quick revision about some notion. Notion number one, it's about the standard solution. A solution of a known concentration is called a standard solution. It can be prepared by dissolving a known quantity of the substance solute in a definite quantity of the solvent. Second, you have to make a revision about three important terms. Dilution is a process of adding solvent water to a solution to decrease its concentration. Concentrated solution, a solution of a high concentration. Diluted solution, a solution of a low concentration. Third notion, it's about the molar concentration C, which is equal to the number of mole of the solute over the volume of the solution. Okay, on a hot summer day, you are thirsty, you need to drink some juice like jalab with your friends Ali and Hussein, for example. How can we prepare jalab juice? To prepare this juice, you need the standard, the mother solution of jalab, water, and 3 cups. You take a volume from the initial solution and put them in the cups, then add water. Ali likes to drink the juice more concentrated than Hussein's juice, and your juice is more diluted than Ali's juice. But in order to prepare solutions from a standard one with precise concentrations, such in lab, we need to follow a specific procedure. In lab, while performing experiments, we need to use solutions of different concentrations. Here in the figure, we have 2 solutions. The more intense one, more darker one, is the more concentrated solution. The second one, more lighter, less intense, is the diluted solution. In fact, to save money and prevent the mess, and maybe for other reasons, the technician buys 1 concentrated solution of each kind of solution that must be present in the lab, and upon need, he or she performs dilution. The question is, how does dilution occur? Each solution has its concentration and its volume as shown in the following table. The standard, the initial solution S, has a molar concentration C, and the solution to be prepared after dilution of S, S prime, has a new concentration C prime. The volume taken from S is represented by V, and you can represent it by V0, V1, etc., while the volume of the new solution is represented by V prime. To make a relation between the 2 solutions, it's important to know that the quantity of matter of the solute present in the solution to be prepared is equal to that taken from the stock, to the initial solution. This implies that the number of mole of the solute before dilution equal to the number of mole of the solute after dilution. Using the relation of the formula of the molar concentration, C times V instead of the number of mole before the dilution, and C prime times V prime instead of the number of mole of the solute after dilution. This implies that the volume that must be taken from S equal to C prime times V prime over C. To prepare many solutions of different concentrations, you have to take in consideration the dilution factor, which is known as fold F, which is equal to these ratios C over C prime or V prime over V. Okay, when calculating the volume taken from the standard solution, we can now make the dilution. First of all, let's indicate the needed materials to prepare a new solution in lab. Beaker, wash bottle of distilled water, volumetric flask, volumetric pipet or graduated pipet, pipet filler or safety rubber bulb, and the standard solution. Please watch the experimental procedure.
determine the amount of stock solution required. To prepare the dilution, we will need the following material: stock solution, a 10 ml pipette, pipette bulb, Erlenmeyer flask, distilled water, disposable pipette, parafilm, and a volumetric flask. Here's our stock solution. We do not want to contaminate it by directly inserting our pipette, so a small amount is first transferred to an Erlenmeyer flask. To use the pipette, place the end in the liquid to be collected. Squeeze the pipette bulb, then securely place over the end of the pipette. Slowly release your grip on the bulb and allow the liquid to rise up the pipette. You should allow the liquid to rise above the line marked on the pipette, but stop before the liquid level reaches the bulb. Remove the bulb and quickly cover the end with your index finger, creating a seal. Slowly lift your finger and allow the liquid to exit until the bottom of the meniscus is sitting on top of the line marked on the pipette. If you allow too much to exit, simply use the pipette bulb to draw more liquid in and try again. This takes some practice, so be patient with yourself. Once you have the required amount of liquid, pull the pipette out of the Erlenmeyer flask and insert it into a new 0.250 liter volumetric flask. Remove your index finger from the end of the pipette and allow all the liquid to drain into the flask. Don't worry if a few drops remain in the pipette. These are calibrated to deliver the exact amount of liquid required. Using the same procedure as before, we now add distilled water to the flask. Monitoring the level and using a disposable pipette for the last few drops. Once again, the bottom of the meniscus should be sitting on top of the line marked on the neck of the flask. Seal the flask with parafilm and gently invert to mix thoroughly. Label your flask. Your diluted solution is now ready for use. Now if you look at them side by side, you can see that the stock solution is darker than the diluted solution.
Now, let's read together the steps that must be followed to prepare this solution. Step number 1, pour in a clean beaker some of the initial solution to avoid any contamination. Contamination means making something impure or unsuitable. Step number 2, take the volume V using a volumetric pipette equipped with a pipette filler. This is the volumetric pipette and this is the pipette filler. Step number 3, introduce the taken volume V in a volumetric flask of volume V prime. Step number 4, add distilled water till the half of the flask and shake. Step number 5, add distilled water with precaution till the line mark. This is the line mark. Step number 6, close the flask and shake well to homogenize. Don't forget that the color of the standard solution is more intense, darker than that of the dilute solution. Okay, let's take a look about the difference between a volumetric pipette and a graduated pipette. A graduated pipette is a glass instrument used to transfer different measured amounts, for example 11, 16.6 milliliter, etc., of liquid material from container to another, while the volumetric pipette is a glass instrument used to transfer a specific measured amount from one container to another, and it's more accurate than the graduated pipette. You can observe here the different graduation, different volumes in the graduated pipette. While in the volumetric pipette, the line mark indicates one volume, such as in this figure 10 milliliter. So the line mark shows a specific volume, one volume. So with a graduated pipette 20 milliliter, we can take 10, 11, 18, 19, 20 milliliter different volumes. While with a volumetric pipette 20 milliliter, we can take only 20 milliliter, one volume from the standard solution. Okay, it's time to do some applications. Application number 1. Describe how can we prepare 100 milliliter of a KNO3 solution of concentration 0.045 mole per liter, starting from a solution of concentration 0.25 mole per liter. You have to show the necessary calculation and the procedure. First of all, let's write the given to make the calculation. This is an important step to solve the exercise. The standard solution S of molar concentration C 0.25 mole per liter. We use this solution to obtain a new solution S prime of molar concentration C prime 0.045 mole per liter, less than the initial one. And the volume that must be taken is represented by V, and it has to be calculated, while the volume of the new solution V prime 100 milliliter, because we have to prepare 100 milliliter solution. The calculation, we have to start with the conservation of the number of mole of the solute during dilution. Number of mole of solute before dilution is equal to the number of mole of solute after dilution. Using the relation of the molar concentration, write instead of N, C times V of the solution before dilution, and C prime times V prime instead of the number of mole of solute after dilution. This implies that V, the volume that must be taken from S, equal to C prime times V prime over C. It's equal to 0.045 times 100 times 10 minus 3. Here we make the volume in liter. From milliliter to liter, we have to multiply by 10 exponent negative 3. We have to multiply by 10 exponent negative 3. Okay, over 0.25, the value is 0.018 liter. At the same time, it is equal to 18 milliliter. This indicates that we have to use a graduated pipette 20 milliliter. The procedure. Put in a clean beaker some of the initial solution to avoid any contamination. Take the volume V 18 milliliter, this is the calculated volume, using a graduated pipette 20 milliliter equipped with a pipette filler. Introduce the taken volume V in a volumetric flask of volume V prime 100 milliliter. Add distilled water till the half of the flask and shake. Add distilled water with precaution till the line mark. Close the flask well to homogenize. Don't forget to memorize the procedure and pay attention that the volume changes with the exercises. As the calculated volume changes, so the graduated pipette changes its capacity and also the volume of the volumetric flask. Application 2. A solution of concentration C equals 0.02 mole per liter is diluted 5 times. Calculate the concentration of the dilute solution. Number of mole of the solute before dilution equal number of mole of solute after dilution. Using the relation of the molar concentration, C times V equals C prime times V prime. Then make the ratio C over C prime equal V prime over V equal F. This is the dilution factor. In this application, the fault is 5 times because the initial solution has been diluted 5 times. Therefore, F equals C over C prime, and then C prime equals C over F equals 0.02 over 5 equals 0.004 mole per liter. Evaluation time. It's required to prepare 100 milliliter of a solution S of concentration 0.1 mole per liter from an initial solution S0 of CaCl2 of concentration C0 equal 2 mole per liter. Available glassware, beakers, graduated pipettes, graduated cylinders, volumetric flask, volumetric pipettes of different capacities. Question number 1. Choose from the above list the convenient glassware with the appropriate volume to prepare with the highest precision the solution as justified. Take into consideration that one withdrawal from the initial solution is allowed and you have to show the necessary calculation. Second, determine the dilution factor default and then describe the experimental procedure of the above preparation. Dear students, pause the video to solve this exercise. Answers. Choose from the above list the convenient glassware and justify. The preparation of 100 ml of a solution leads us to use a volumetric flask 100 ml. And to avoid any contamination, we use a beaker 50 ml to pour some of the initial solution. Calculation: number of mole of solute before dilution equal to the number of mole of solute after dilution. C0 times V0 equals C times V. Then V0 equals C times V over C0. V0 is the volume that must be taken from S. Okay, V0 equals 0.1 times 100 times 10 minus 3 over 2 equal 5 times 10 minus 3 liter equal 5 milliliter. And since a volumetric pipette 5 milliliter is available, we use it to take 5 milliliter from the initial solution. So the materials are volumetric flask 100 milliliter, beaker 50 milliliter, and a volumetric pipette 5 milliliter. Second, determine the dilution factor. The same relation must be used. C0 times V0 equals C times V. Then we have to make the ratios. C0 over C equal V over V0 equal F. This implies that F equals C0 over C, 2 over 0.1 equal 20 times. So the solution has been diluted 20 times. Okay, the procedure. Put in a clean beaker some of the initial solution to avoid any contamination. Take the volume V0 5 ml using a volumetric pipette 5 ml equipped with a pipette filler. Introduce the taken volume V0 in a volumetric flask of volume V equal 100 ml. Add distilled water till the half of the flask and shake. Add distilled water with precaution till the line mark. Close the flask well to homogenize. This procedure must be memorized. Okay, please resolve the application and the evaluation exercises. Memorize the procedure on page 8 from worksheet 4 in your chemistry booklet and solve part B from worksheet 4. Thanks for your attention. Stay safe. Goodbye.